Hey, anatomy students, um, welcome back from spring break. Hope you had a great spring break. Today we continue on with the immune system, lymphatic system, and before the break we talked about how specific things invade our bodies, and we really focused on COVID-19, the coronavirus, and the pathway into the human body. We want to finish the unit talking about how the human body would eliminate an invader, and there are two different ways that's going to happen. So let's get into this. First, you must know some terms. Specific resistance is the human ability to defend against specific antigens or pathogens. But we have to learn how to do that. We'll talk about that. We already know what an antigen is, a substance recognized as foreign that will provoke an immune response. So antigens will help us learn how to eliminate the invader. And then immunocompetence is the ability to carry out the immune response. So once the human body recognizes the invader, immunocompetence would be the ability to successfully rid the body of that invader. I want to show you this flowchart, just a little bit of review, just to remind you of how many different types of white blood cells we have. So we've talked about the macrophage, which is a phagocyte. It eats. We talked about the neutrophil, another phagocyte. We did not talk about the eosinophil or the basophil. We know about platelets already. So to finish this unit, we really want to focus on the T cell and the B cell, with today's lesson being about the T cell. But let's go to those two different types of specific immune responses. So our big focus today will be cell-mediated immune responses. These involve T cells. And I call these the warriors. If we keep this military analogy, T cells fight. They will destroy infected cells. CD8 is the specific name of that T cell. And then a cytotoxic T cell just means a T cell harmful or toxic to cells. Cytotoxic T cells will get rid of pathogens that get inside human cells. So bacteria can do this, fungi can do this, worms can do this, viruses always do this, especially COVID-19. We talked about how COVID-19 invades epithelial cells in the lungs. CD8 T cells, cytotoxic T cells, will also get rid of cancer cells. And then unfortunately, the reason why people cannot keep implants around very long is because our own bodies start to attack those foreign tissues. So let's say you get a brand new heart donated from someone else. Your body over time will start to attack that heart because it recognizes that heart as not you, it's someone else. The other response we will talk about later on this week, the antibody-mediated immune response, and that will involve B cells. B cells will become plasma cells, and those plasma cells will secrete antibodies, which will also attack invading pathogens. So two different ways, two different specific ways to get rid of invaders. T cells, warriors. B cells drop bombs, and those bombs are antibodies. How do these things invade? So some things get in through our bloodstream, like a lot of bacteria can get in through cuts, like hepatitis can get in through our bloodstream, like HIV can get in through our bloodstream. When they do, the spleen is oftentimes the battlefield where we will fight off that antigen. Some things can penetrate through our skin. So this could be bacteria also. This could be viruses. This could be worms. And a lot of times our lymph nodes will fight the battle. And then some things can penetrate through our mucous membranes, mucosa associated lymphatic tissues, MALTs, so our eyes, our nose, our mouth, etc. This is what a lot of viruses do, like the flu virus, COVID-19, cold viruses get into our bodies through our mucous membranes. Antigens, remember, are mostly proteins. So in the last lesson from before spring break, we talked about how the COVID-19 spike protein or spike antigen is the protein that will attach to the lung cells to allow the COVID-19 virus to penetrate into those cells, to take over those cells. Our bodies can recognize up to 1 billion different antigens. So that pretty much takes care of anything in the environment and would also take care of our ability to recognize this novel coronavirus. Novel coronavirus meaning a virus that we've never seen before on Earth. Our bodies can still recognize it with our immune system to try to eliminate it from the body. All right, let's get into T cells. Cell-mediated immunity. First thing that has to happen is T cells have to be activated. So in other words, they're rolling around your body, they're rolling around your lymphatic stream, they're saying hi to all the things that they recognize, then all of a sudden they see a cell that doesn't look familiar to them. And they're like, hold on, I don't recognize you, cell. And that's what activates a T cell. When they're activated, they proliferate, which basically means they are cloned. And this is what I call building the army. So they're rolling around and they're saying, all right, I don't recognize you, cell that's been invaded by COVID-19. And they say, all right, because I don't recognize you, I am going to clone millions of T cells to try to take out the COVID-19 infected cells. And that's the elimination of the intruder in step 3. And we'll talk about how that specifically happens at the end of this. This could happen in your tonsils. This could happen in your lymph nodes. This could happen in your spleen. Remember, these are the battlefields where we fight disease. And I've just read actually today about how some people are experiencing swollen lymph nodes when they get the COVID-19 infection. So I had not heard that until today. So, and that makes sense. If we need to fight disease, we need to take those viruses to the lymph nodes to eliminate them. A few types of T cells. Helper T cells are also known as CD4 T cells, and their job is to clone the army. So they're activated, they recognize an intruder, and they produce these chemicals called cytokines, which produce millions of T cells that will attack the invaders. Remember, immature T cells are made by our bone marrow. They then go to our thymus gland. In our thymus gland, they become mature. Remember, the thymus gland sits the lower section of your neck, right on top of your heart. Helper T cells, like I just said, release these yellow dots, which would be the cytokines, to produce an army of T cells, and that army of T cells would be these cytotoxic T cells, the warriors inside our body. So cytotoxic T cells, also known as CD8 T cells, they are able to recognize antigens found on our body cells that have been infected already, cancer cells, tumor cells, and transplant cells like a new kidney or a new heart. This is what that looks like. So there's an infected cell down here, and these little red things are the viruses. Could be COVID-19, and this could be like an epithelial cell in the lungs. Cytotoxic T cells would attach to those infected cells in our lungs to then kill the infected cells. So, yeah, I said that. We actually kill what used to be a good cell in our body. Um, but it's not a good cell anymore. It's been taken over. COVID-19 has taken over that lung cell. And that's how these viruses can be so destructive to the lungs, especially COVID-19. That's why people are getting pneumonia because they're getting all this buildup of just bad lung cells. And that oftentimes will produce mucus. Although with COVID-19, we're seeing a dry cough instead of a wet cough. But we're definitely seeing on CT scans areas of the lungs that just are not working very well. So yeah, these cytotoxic T cells have to get rid of these infected cells. And then finally, the last type of T cell is a memory T cell, and they obviously very simply remember that virus. They remember what infected that cell. If that thing gets back into our bodies, they will get rid of it before it causes disease. So with COVID-19, I don't know that we have any proof that anyone has gotten the disease twice, and they shouldn't, because you should, once you recover from the disease, you should have memory T cells that will recognize it if it gets in your body again to wipe it out before it causes pneumonia a second time. And in theory, for most diseases, this should be for 20 or 30 years that you can remember that disease. Now, if COVID-19 mutates, that's an issue because then you would not be able to recognize it anymore. And that's exactly what happens with the influenza virus every year. You can get it every year because it mutates every year such that your body can't remember it, your body can't recognize it anymore. So with memory T cells, you should rarely get a disease twice. Now, how do the T cells actually kill these infected cells or cancer cells or transplant cells? And this is going to be pretty wordy. So we already saw in that previous picture that cytotoxic T cells bind to infected cells. And here's the first thing. They release granzymes. And granzymes will go into the infected cell, usually at the nuclear level, at the DNA level, and trigger the automatic death of the cell. So basically, it will blow up the cell from the inside out at the nucleus, which runs the cell. Phagocytes will be there to clean up anything to clean up the mess. So you have your neutrophils, you have your macrophages that are called to the area to chomp away at anything that is bad that's released when we kill the infected cells or the cancer cells. A second way that T cells kill infected cells is they release two things called perforins and granulysins. And literally, perforin is a form of the word perforate. Now, I don't know if you know what the word perforate means, but it means to punch holes in something. So literally, these chemicals punch holes in the infected cells. It disrupts the homeostasis of the cell, and it kills the cell. The other chemical, granulysin, causes the cell to burst or to fragment, and that would kill the cell also. And the phagocytes would be there to clean up the mess after that also. I want to finish by showing you this picture. The big cell is a cancer cell. The smaller cell below it is a cytotoxic T cell warrior, and you can see that perforins have been released, and there are holes in the cancer cell, and this cancer cell cannot live when there are holes in it. So that will kill the cancer cell. And the same thing would happen with COVID-19, influenza, common cold, where we would have these strategies to kill infected cells. And that's it. So hopefully you got all of that. Um, we will have a short little quiz over what I just talked about to finish off today. If you have any questions, let me know.